on here is another example. This is going to be problem 1413 out of Shigley. The gear set has a module of 5 millimeters, so we're in SI this time, a 20-degree pressure angle, and a 24-tooth cast iron spur pinion driving a 48-tooth cast iron gear. The pinion is to rotate at 50 RPM. What horsepower input can be used with this gear if the contact stress is limited to 690 megapascals and has a face width of 60 millimeters? So let's take a look. Here is the problem written out on a piece of paper. And let's see where I have right here. Okay. So a good starting point is always to take a look here with our information provided and get the diameters. So the diameter of the pinion, now this time it's the module times the number of pinion teeth, right? So it's a 5 millimeter module, 24 teeth. That comes out to 120 millimeters, which is like 6 inches, by the way. For the gear, I decided to go lowercase g this time. So the number of gear teeth is 48, so that's going to be twice that. I can do that in my head, 240 millimeters. And we're going to need the pitch line velocity. So we get the pitch line velocity here, and we get pi d n. But now we're going to divide by 60 and divide by 1,000 right here, because that's going to get us into meters per second, right? So I might want to look up and say there's a, let's say a 50 RPM, right? We want to make sure that we're using the same diameter, right? So if the pinion's going at 50 RPM, we use the pinion diameter. And that 60 turns that minutes into seconds. And we'll then take our millimeters into meters, and we end up with 0.3142 meters per second. And I think we have to make a guesstimate or a decision maybe on what kind of gear we're dealing with. Well, these are cast iron, so maybe when we go to use a dynamic factor, we will use cast right here. So there you go. We will then use to cast, and that's what we did right here. We have to be careful right here that we're using, it says right there, use V is in meters per second, so this is the SI versions right there of this equation. So for the KV, we take 3.05 plus V over the 3.05, and so 3.05 plus 0.3142 over 3.05, and we get 1.103. What we learned from that is it doesn't have a lot of effect, right? This 50 RPM doesn't have a lot of a dynamic factor put onto there. And we can look up for this cast iron and cast iron. Let's just take the CP from that table, right? So the table 14.8, and you know, it wouldn't hurt to go ahead and there's going to be a lot of tables and so forth, but to carefully put out little tabs onto your page. And if you decide to sell your book, maybe you want to put them on something that's easy to remove here. But we're going to have cast iron, and you note that we're going to have SI in parentheses below right here. So I think cast iron and cast iron, we have 163 with a units of square root of megapascals right there, right? And note that sometimes they call it ZE. I don't know. Sometimes they call it there, right? So wouldn't hurt, you know, for speed to get these things as a put the tabs in there. That's all I'm saying. All right, so this what we looked up here. So we got to be careful with our units when we go to use our equation, which remember is going to be this equation right here for our this. Okay, so that we were given that the limit was 690. So I'm going to go 690 e to the 6 right here, right? I like to stick in with basic units when it gets confusing, right? If there's ever going to be some confusion right here, I go back to, let's go pascals, which is a Newton per meter squared, right? And we're going to equal to a negative, well, we don't really need the negative in there, so let's ignore the negative. It was a silly in there. We need CP, so that's 163 right here. But it's going to be e to the 3, right? So I want to get that. I want to get that right because that's the square root of megapascals. I want to get the square root of newtons per meter squared to be compatible with this. And then dynamic factor, we just found that 103. We're going to look for this, right? We're looking for what the power is going to be. Face width is 60 millimeters. So let me put these in. This is meters, 0.06. Cosine, they said a 20-degree pressure angle, so 20. And then, I think I didn't do this yet. I need to do this over to the side, maybe. I did it up here. So the RP of this is going to be 120 times the sine of 20, right, divided by 2, which ends up being, I think they ended up being 20.52 millimeters, right? When we put them up here, make sure we're putting them in meters. And then RG, similarly, it's just going to be twice that, right? Because it's number of teeth was twice the number of teeth. So that was the 41.02 millimeters. So let's put this back up into here. We have that is going to be 0.02, yep, 52 plus 1 over 0.04102. And make sure we have that whole thing square rooted right there. So we do a little bit of manipulation here, and we're going to find out that we have a transmitted load of 12,530, and they come out to newtons because we were careful to not play around with the bigger units here. So now we go, we want to find out our power with this, and I decided to use the equation from 1336, right? So I jump back to chapter 13 and equation 1336, if I can find it. It's not there. I just want to show you where it is in case when you go to look for it. I think it's right there in the force analysis section. Yeah, right in here. So we can find what the power is from this, right? So it's just manipulating around to find what and that's going to be, if we use this equation, we get kilowatts right there. And but also the transmitted load needs to be in kilonewtons when we put it into there. The diameters in millimeters, and the RPM is RPM. The speed is RPM. Okay, so that's where we get that equation from. So we get power is going to be, see, I wrote down, let me just write down what that equation was. Okay, equals 60,000 times H and raised to the pi d n right here. That's in millimeters, that's kilowatts, that's kilonewtons right here. So we find out that the power, I used 12.53 for my kilonewtons in here, multiplied it by pi, did my 120 millimeters and my 50 RPM, and I divided it by the 60,000 factor in here, and I get 3.936 kilowatts. I could also, by the way, if I wanted to, take my WT and multiply it by my pitch line velocity, and I had 12.53 kilonewtons, and my pitch line velocity was meters per second right there. So I'll have a kilonewton meter per second, which is so this was 0.3142. So we get 3.936 kilowatts. And it still looks like a kilonewton. Ta-da. End of example.